Hello everyone, my name's Dane. In this video, we're going to be jumping on the ChatGPT bandwagon to see what it can do for us in the fields of reliability engineering and asset modeling. So here we are with a brand new ChatGPT chat session open. And to be honest, I haven't played with it too much, so I'm not sure what its full capabilities are. But the way I'm going to approach it is just ask it a bunch of leading questions that I might typically ask it in my day-to-day job and see what type of quality answers it comes up with. And we'll start with something pretty simple. Let's see, I'm gonna type this. Can you give me an example of a FMEA for an electric motor? Okay. Let's see what it comes up with. Okay, so you can see it's identifying different failure modes, which is a good first start. I have the effect of each, and it's giving it a RPN rating, or a risk priority number rating, which aligns to the FMEA definitions. So this is pretty interesting. It's only given us 3 failure modes as an example, but it's kind of illustrating the structure of what FMEA should look like for an electric motor to start with. Now, this is just an example. It would likely include many more failure modes, and I guess the effects and mitigating actions are business dependent, right? So you can't really read into this number too much. I wouldn't copy and paste this for your business and your application. You have to rate it for your specific context. But let's see if it can give a bit more detail. So can you please give me more detail? Perhaps 10 failure. Now, one thing that's really interesting with this is it, as I understand it, it maintains context. So if you ask it a question previously, it'll still have that in its memory and be able to elaborate on that a bit more if you want to. So let's see if it can give us some more. We've got insufficient insulation, overloading failure mode, vibration and noise, bearing failure, lack of lube, yep, contamination. Okay. It's also giving some mitigation information as well, which is interesting. Electrical interference, all right. Component fatigue, it's a bit ambiguous, but okay. Power supply issues, sure. Water damage, maybe dust ingress or something for the last one. Let's see. Software control issues. All right. Okay, so it's drawing from some existing FMEA on motors, so it can contextualize the failure modes pretty well, which is it's interesting. All right, what next? I mean, we can keep going down this path, but it seems like it can give us a good start for a FMEA or FMEA as to where we should be looking. Let's try a different type of question. What is the typical design life for a power transformer? And you can see I'm an electrical background too, right? So I'm digging into electrical assets, but I'm assuming it works the same for mechanical ones as well. 25 to 30 years. Okay. It's putting a caveat there saying it's depending on different factors such as quality of materials and components, which is very true. And I'm wondering where it gets this info from, because a lot of the power companies here in Australia, at least, have transformers that are well beyond 30 years. The design life for them, if I remember correctly, is something like 60 years. So it must be drawing from an existing body of knowledge there for that. Okay, it gives us some interesting ideas around trying to extend the life or maximizing the life around regular maintenance and so on. All right, well, let's dig into power transformers a little bit more. What is the dominant end of life mode for, let's make it a bit more explicit, value mode for a power transformer? Typically due to insulation failure. Yeah. Winding failures, bushing stat changes. Yeah, I wouldn't typically consider some of these other modes as end of life failures unless they're catastrophic. But yeah, usually insulation. So I think it's got a pretty good idea here. Fully recommended maintenance practices. Yeah, all right, fair enough. What about, let's say, what activities can we do to extend the life of the power? What I'm trying to get at here is, does it recommend a decent maintenance strategy or tactics to perform to try and get more out of an asset? So proper installation, regular maintenance, load management, okay, high quality components. I mean, most of these things are pretty obvious, but it's good that it spells it all out for you. If you're building asset management plans or documentation around how you're going to operate, maintain, and use an asset, here's a bunch of text that you can almost copy and paste into your asset management plans and make sure you've covered all of the bases in terms of the tasks that you're doing, which is pretty useful. Okay, so what about failure distributions? Let's see if, can you estimate Weibull distribution for value modes? Can you estimate Weibull distribution parameters? Okay, so hopefully it draws on the failure mode. Whoops. Failure modes from above. Oh, it even recognized my spelling mistake here. Okay, so it's telling me about the Weibull distribution, which is good background, but I'm wondering if it can actually estimate any. Okay. All right. Okay, let's try again. Can you estimate? Oops. Can you estimate the Weibull distribution parameters for, let's say, insulation failure? Okay, I think it's just spitting out the same thing again. Okay, I'll stop generating there. So I'm guessing it doesn't really have a data set to draw from for this. I mean, obviously the parameters are going to be dependent on a whole bunch of different things, which it's pointing out. But for a starting point, it doesn't seem like we can get something out here. So let's change tact a little bit. Let's have a look at inspection sheets. So can you write an inspection check for power? Change this. Okay, writing this incorrectly, but it understands. Okay, physical inspection. Exterior check, signs of leakage, yep, proper labeling, name code, yep, proper ventilation. Okay. Then it goes into some of the electrical tests, winding resistance testing, insulation resistance testing, tap changer operation, bushing operation, oil level, maintenance inspection. I'm guessing it's more mechanical. Records, oil. So this is all great stuff. If we're writing inspection check sheets or making sure that we've got all our bases covered, this is a really, really good start. I'm surprised at how much it knows. Now I've heard that ChatGPT, because it's essentially operating on a snapshot of the internet from maybe a couple of years ago, a lot of this information is obviously coming from existing websites or vendors or consultant web pages or whatever it is. And so it'd be interesting if we could find out where it's getting some of this information from, just to kind of avoid plagiarism and crediting the authors and so on. But yeah, okay, fair enough. All right, how about we ask it about predictive and Conmon techniques? So can you tell me what predictive or condition monitoring use? Let's see what it comes up with. DGA, good. Ultrasonic testing, yep, that's used as well. Thermography, PD tests, voltage current monitoring. All right, these are all heavily used in industry. Vibration, I'm not sure that there's too much vibration monitoring being done on transformers, but I could be wrong. Okay, interesting. What else can we ask it? What about some like different asset specifics? So what are the types of bushings that can be used? Two main bushing types, IP and porcelain. Okay. Vulnerable to moisture and oil leaks. Yep. Porcelain is good, but more expensive. True. Wonder if it can tell us any other ones. Are there any other types? Including epoxy resin. Yeah, nice. So just, we can keep going. Silicon rubber. Wow. I'm impressed. It seems like a really good learning resource. I'm not sure from like an asset modeling side how much technical information we can get out of this. Most of it is just text copy and paste from somewhere else, but if you haven't had exposure to an asset class before and you're asking basic questions to kind of get up to a level to understand the asset really well, this is a great resource. All right, let's get into some maintenance strategy stuff. So how would you optimize a maintenance strategy for a pump? Let's see what it does here. What I'm trying to do here is not to trick it per se, but ideally your maintenance strategy will be contextualized to your business conditions and risks and values and all of that kind of thing. And to optimize it, you're trying to optimize to essentially a value function. And I'm trying to trap it to see if it gives me a specific strategy and says, do this. But it doesn't seem to be doing that. It's saying you need to define your objectives, conduct your own risk assessment, implement predictive maintenance. I mean, I wouldn't go as far as to say do X, Y, and Z, and unless it's cost beneficial for you to do so. But okay, at least consider predictive maintenance. Develop a maintenance schedule based off obviously the objectives and risk assessment and so on. Establish a spare parts program, monitor and review, involve the team. So this method here isn't particularly an optimization method. It's more a continuous improvement. How do you start with something and iterate on it and build on it? So it's got the question a little bit, maybe I'm not too clear, but it's not directly answering the question that I've asked, but it's still a pretty good start. Okay, give me let's try and get it to give us some specific examples. Give me a typical maintenance strategy for let's get an electric motor. Initial assessment, okay. Maintenance schedule. I think it's giving me something different. Implement predictive maintenance. So it's kind of giving me a few different things that we can do. But for a strategy, I really want to know how often should I be doing them and how that links to my objectives. Let's see if it can give us some frequencies. So how often should these checks be done? Yep. Okay. 3 to 6 months, just as a kind of general guideline. Can you give me an example table consisting of past and amended frequency? Cool. So it's basically blanketing everything 1 to 3 months. Obviously, it has no context here, but winding inspection 1 to 2 years, general example, and it caveats it too, which is good. What if I said update this table for an electric motor with high, let's say large consequence. Monthly, weekly. Okay. So obviously it understands that there's this variance between, or not variance, there should be an adjustment in strategy when the asset has higher consequences of failure or higher business risks. Therefore, it's like increasing the benefit of doing some of these inspections. So it's really good to see that it makes that relationship. It's just blanket increasing everything across the board, which doesn't really make sense, but it understands that there is a relationship there. So, okay. What about, let's ask it some like high level questions, some portfolio level questions. So let's say, how would you determine assets? Okay, How would you determine which asset to prioritize your maintenance if you're resource constrained? So it's starting with essentially what's a criticality assessment, or the ones with the highest consequences, assesses the risk, prioritizes the maintenance activities. Similar to the approach above. So utilize preventative maintenance, consider the cost of downtime. Okay, that should fall into the assess risk and identify critical assets parts, but that's okay. What about, do you know of any methods that can be used to optimize the allocation of resources? Pareto, critical path, linear programming, Monte Carlo sim, resource level. Okay. These are all highly used methods, by the way. So all of these have their own sort of benefits and strengths and weaknesses. Typically, resource allocation problems, at least in my experience, some of the more complex ones, they are solved using linear programming approaches. So let's see if it can help us out with that. So what if I ask it, can you write me a linear programming example? Can you write me a linear programming example that takes in resource levels and consequences, and for example, let's say in Python, let's say we want to use Python, resource levels and consequences, and analyzes resource level allocation based on target values for production. Let's see how we go here. Okay, so it's using pulp, which is a library in Python that contains a whole bunch of different mathematical optimization techniques, and it sets up a linear programming problem here. It defines the objective function. Okay. Obviously, these are dummy values that are being put in here. And this isn't going to give us anything useful straight away. We will need to refine this problem and to make it usable. But no, it looks like it's got this, at least the right library and the right structure for it. It defines the objective problem. It defines the the objective function. It defines the problem and then just solves it. So we need, if we were to use this in a day-to-day application, or as an auxiliary to a separate process that we have, we will need to turn this into a method. So let's see if we can. Can you write this as a method that takes the constraints and targets as inputs? Okay, so it's going to do the same thing. It's going to modify it. It creates a method here that takes the resource levels and the targets in, and then sets up the problem, and should return the result. So problem, and returns the value, the production value that it's achieved. Yeah, cool. It comments it and everything, which is really awesome. And then it goes on and explains it. So you can almost copy and paste this in. Obviously, this isn't going to solve a, a usable business problem straight off the bat. But if you iterate on it like I'm doing here and just ask it to refine things and change things, and you understand exactly what it's doing, there's no reason why you can't go from nothing to a fully solved linear programming optimization method straight in ChatGPT here, which is super powerful. At least the coding aspect of it is like really, really cool. Okay, so one more. I'm going to try one more iteration on this. Can you rewrite this method except a number of assets and their consequence as inputs? Have one more look at this. Okay, so it takes in resource levels, assets, and consequences. You probably want to do another iteration to take in the targets as well. So it's doing assets times consequences. Yeah, okay. Yeah, we still have to iterate on this a bit more, but no, super interesting and super like efficient. If you can understand a business problem that you're facing and articulate it in a way that ChatGPT can spit out some code for you, and then you can just copy and paste it in and play with it. Yeah, I'm blown away. So this is super useful. I think I might leave it there. In conclusion, it seems like ChatGPT has a really, really large underlying sort of repo of knowledge that you can draw from. It doesn't seem like it can make conceptual jumps into things that haven't been tested yet. But in terms of starting from a blank slate, going to ChatGPT, getting task lists, getting failure modes lists and templates for FMEAs and things like that, and templates for optimization techniques like this, super useful resource, super useful resource. So if you can think of any other applications for this, or things that you want me to test, chuck it in the comments below and I'll have a look and get to it. But that's it for this video. Hope you've enjoyed it. Smash the like button, smash the subscribe button, and I'll catch you in the next one.